Hello once again. We are taking a look now at what would be our example 2 from Larson's section 4.1, basic antidifferentiation. And we're ready now to start tackling the integration of the trigonometric functions, and we're talking about the 6 basic integration formulas, not necessarily the 6 basic trig functions. There is a big difference there. And if you notice that the contents of this box contain 6 integrals where the integrand, that would be the expression after the integration symbol, all seem very familiar. And if you take just a deeper look, you perhaps would realize that these are the 6 different answers that you would get from taking the derivatives of the 6 basic trig functions. Oh, perhaps maybe missing a negative sign here and there. So if you take a look at the first one, the integration of cosine, you just have to kind of ask yourself, what is it that you take the derivative of that would produce an answer of cosine? And of course, that particular answer would be sine of x, the positive sine of x. And as with all indefinite integrations, you must remember to put a plus c at the end. Now we'll do the same thing, and I'll tell you what, I'm going to work down here. I'm going to go ahead and take a look. Well, I'm going to take that back. Let's just go ahead and work across. These aren't in any particular order per se. Let's go ahead and look at the integration of sine of x. You'd think, okay, well, what is it that you take the integration of that would produce an answer of sine? Well, there really isn't a basic derivative that you take. You can take the derivative of cosine, but that gives you negative sine. Now we have a result in our integral here of positive sine. Well, as you guessed it, all you need to do is just place a negative in front of that cosine, and you've got your answer to this integral. All right, now to kind of recap this going backwards, if you were to take the derivative of negative cosine, you already have a negative. The derivative of cosine is negative. 2 negatives would cancel, giving you the positive. All right, taking a look at the integration of cosecant squared. If you think about what is it that you can integrate that would give you cosecant squared? Well, let me see. If we integrate cotangent, the integral of cotangent would give us negative cosecant squared. But the integral of cosecant squared, which doesn't have the negative, means I'm probably going to have to put a negative in front of my result. And then if we go with the cotangent here, we should have our answer. All right, now once again, let's think about this. The integration of cotangent is negative cosecant squared. But if we already have a negative on this side, it's going to cancel the negative from our derivative. Taking a look at the integration of secant squared. The integration of secant squared, well, much like the integration of cosecant squared, it's going to result in a similar situation, but of course we're going to have the tangent. Now if you reason this backwards, the derivative of tangent is secant squared. Taking a look at the integration of cosecant cotangent, we can think that, okay, we would take the derivative of cosecant to give us negative cosecant cotangent, so the integration of cosecant cotangent must be negative cosecant. And for similar reasoning, the integration of secant tangent, you guessed it, secant. Now, one might wonder why I decided to list the integrals in this particular order. Well, you see I have all of the integrands that begin with the letter C over here. And if you recall, in the differentiation techniques, we discussed that if you take the derivative of a trigonometric word that begins with the letter C, your answer is always negative. The derivative of cosine, the derivative of cotangent, the derivative of cosecant, all had negative answers. Well, things are a little different with integration. If you take a look at your answers, the 3 that start with the letter C, you can tell all are negative. So that's a great way to remember at least the signs of 3 of these 6 integration formulas. Now, typically speaking, in beginning calculus, you really don't have too difficult of problems that will be presented to you where you're integrating using these. For example, 2a, the integration of 2 times the sine of x, well, you've got a constant of 2 that just drops straight down. And then when you integrate sine, well, we could just go right to our formulas up here, and we see that we get negative cosine. Well, 2 times negative cosine, we could float the negative out to the front, and there we have it, negative 2 cosine of x. Now, once again, don't forget the plus c, very important. Now, let's take a look at example 2b really quickly. Now, this is a little different. When you integrate sine over cosine squared, the first inclination would be to try to integrate sine, which is negative cosine, and somehow put that on top, but that's not going to work. Besides, you're not going to be able to integrate cosine squared very easily, at least not until you get to calculus 2. So what you're going to have to do in this situation is develop some kind of a scheme to change this integral, because let's face it, right now you only know 6 integration formulas, and this needs to look like one of those 6. So if you play around with this a little bit, maybe you decide, oh, well, we could split apart the cosine squared, right, maybe into a cosine of x, and then there would be another cosine of x, I guess, in the bottom. Might have to put a 1 there on top just to hold that position. And we look at this a little bit further and we see, sine divided by cosine, is that something familiar? Sine over cosine, well, yeah, that's tangent. And 1 over cosine, that's the same as the secant. So we're asked to integrate tangent times secant, which is the same here as secant times tangent. So the result of this is just the secant of x. And then once again, don't forget your constants. If you find that you're the type of student that really struggles in memorizing the derivative formulas for the 6 trig functions and then these particular integrations, I highly recommend that you use some kind of a flashcard. You can write the integral problem on the front side, write the answer here on the back side, and make sure that you look at them. If not every day, maybe every other day, and I guarantee it'll go a long way. I've had many of my students who've had trouble just flat out memorizing these, sort of adopt that strategy, and it's made a big difference. So these are your basic integration formula for your first trig functions.